Welcome to the ViniMark podcast, a collection of interviews with thought leaders of the wine world, brought to you by ViniMark.
There's a big tendency today to use normal cameras. We have been working in projects to detect leaf roll. We finished the first phase of that project using images from a cell phone. It's able to detect if the leaf is infected or not. In the past, we worked in a couple of projects using technology from video games, Kinect sensors, to calculate the 3D structure of plants and also bunches. We find very interesting approaches when people was using computer vision support systems to help laborers in the vineyards to take certain actions like a bunch thinning. So which bunches should be removed. So the system is telling to the person with colors, okay, cut this bunch and keep this one. We are doing a calculation of the amount of water that is needed with real-time sensors. There's sensors that can be used to detect unconscious signals of people when they test wine. Wine marketing, I think, is something extremely powerful that's going to happen probably soon.
That was the voice of Dr. Carlos Poblete Echeverria, Associate Professor in Digital Viticulture at Stellenbosch University, working within the Department of Viticulture and Enology at the South African Grape and Wine Research Institute. Now, in this episode, we dive into some of the most cutting-edge advances in viticulture, from high-resolution soil mapping to real-time vineyard analysis, measuring everything from water stress and disease pressure to detecting leaf roll virus with nothing more than a cell phone camera. We also unpack some surprising structural advantages within the South African wine industry, things that may quietly position us ahead of the curve as the future of wine becomes more volatile and data-driven. And yes, we even touch on South Africa's first steps into the wild world of vineyard robots. Professor, thank you so much for joining us today. It's been something that I've really wanted to explore because for about a decade, I think I've been hearing winemakers talk about wanting to get more and more granular. And we had NDVI tech where we were starting to look at vineyards as subsections and even going down as granular as vine by vine. But as we get obsessed with zooming in, a question popped up in my mind when I think back to the consumer or lovers of really fine wine. The kind of highest expression of site or terroir is still a single vineyard wine. And I wondered, is there really a need for us to drill down vine by vine if the consumer only really appreciates things as a vineyard or block by block?
Yes, thank you for the invitation and for the question. I think you're right. So the terroir is an extremely important concept. It's the one that generates the ambient conditions in terms of the plants that we are using and also historical perspective of that particular area. But these new technologies are not trying to replace that concept. Actually, we are talking about digital terroir. So we want to understand better what are those conditions that can generate that unique wine in certain areas. So mainly the technology is going to help us to understand that, to manage the variability that is inside of the blocks in those homogeneous units, and also have a better expression of that variability for the wine that the people want to produce.
What are examples of the sort of variability that can exist within a block? Surely farmers have divided up their blocks in accordance with a soil type anyway. That would seem like the logical thing to do.
Yes, that is true. So the most important is to have a good analysis of the soil initially, and then you can generate your blocks or your areas using that information. And in general, it's very important for the logistics because traditionally they can manage only what happened in that block. But we have seen in our studies more than 40% of variability in blocks that are considered homogeneous. The main source of variability is the soil, but also there's plenty of expression of different variability. So if the soil is fairly similar, the plants can still express certain conditions by the microclimate, slopes, and different levels of infections that can happen in a block.
What I'm hearing is there's two phases where these new technologies are going to be implemented. And the first is in vineyard planning, because you now can analyze soil far more accurately. What would that look like? What sort of processes are available now that weren't available, say, 10 years ago when it comes to plotting soil graphs or soil maps?
No, there are very interesting new technologies. For example, today it's very common to use electrical conductivity. So that is a technique that you can mount a sensor in a quad bike or in a tractor and pass through the soil together with GPS, collect multiple points in an area that you want to analyze. And that electrical conductivity is linked with certain physical properties of the soil and also react to the salinity. We can identify areas if they're homogeneous or not, and using that information to split the blocks properly. So the traditional technique is soil analysis, but obviously that is time consuming and expensive because to have a proper characterization, you need multiple points. So electrical conductivity is today the method that can help you to analyze a big area in a more dense way with less effort in terms of logistics and also with a better cost. That is extremely powerful because you can take good decisions from the beginning, because the ideal is to have the vineyard running for a long period. But to do that, we need to consider that very fine detail in terms of soil analysis, climate conditions, having some potential ideas of what happened with that climate in the future. Later, when your vineyard is established, it's a little more complicated because you don't have that flexibility to adjust. It's extremely complicated to make some modifications in the soil or changing your structure of the vineyard, changing the positions or changing angles, etc., etc. So that is why I mentioned this initial phase of establish a new area.
There's a company called Terraclim that takes all these sorts of information points or data points and then layers them all over each other and can make correlations between your little spot in the ground and any vineyard in the world. And what I loved about that idea is that you could be in Bloemfontein, for example, and discover that one little patch of your farm has the exact same conditions as maybe somewhere in Piedmont. You can have this totally random correlation, but discover that this little patch in a region that is never been considered a wine-growing region could now match one of the most famous wine-growing regions in the world. I find that really interesting. It almost removes all barriers or preconceptions about where we think grapes can grow. Would you say that's a fair hope?
Yeah, no, that is a nice concept. I have been working in that same idea for many years. My previous experience was in Chile. So we established a project like that 15 years ago, exactly with the same concept in terms of analyzing bioclimatic indexes and characterize the climate. But that focus in that case is climate related with that area in particular. And it's extremely interesting because, as you said, we can compare different valleys, but then that is the climate part. So then on top of that, you need to do the rest. So that is your viticulture practices, what type of cultivars you have there, soil conditions. But it's an extremely nice angle. I don't know if someone is taking that more in a commercial approach, but this a concept had been in the literature and the science for many years.
One of the other things that popped up in a discussion about all the data that is being gathered now is that you still ultimately have a human who is the decision maker at the end. You might have driven your quad bike through a vineyard and seen that it's this type of soil with this kind of moisture retention at this aspect and this proximity to the ocean. Therefore, you should plant Carignan. But the farmer might still say, but I don't want to because no one's going to buy Carignan. I want to plant Cabernet. So it's funny that we can have all of this data and it can give us very high probabilities of success in a certain area, but the human still has to decide whether or not they're going to act on that. And some of the stories hearing where there's some very famous estates in Stellenbosch who shall remain nameless, who once they've had their terroir evaluated, it's been discovered that they are absolutely perfectly designed for Sauvignon Blanc. But there's no ways that they're going to plant Sauvignon Blanc because their brand has been built around something completely different. I suppose that's one of the friction points between this amazing advance of these AI technologies and the fact that there are still humans and farmers who are the ones who either use that or don't.
Yes, you're totally right with that idea. It's difficult for us as a human to consider multiple factors at the same time. So that is why the people tend to have consultants, technical advisors for certain areas, because the producers, I'm pretty sure they're looking options that can maximize the return and investment. So it's not a single answer, but from a digital viticulture aspect, it's new techniques, new things happen. Our idea is to try to promote those techniques as a decision support system. So it's more information, easy to access, giving options to the people to take better decisions from an initial phase, then also for daily activities, for example, irrigation. So we are running new projects now. We are doing a calculation of the amount of water that is needed with real-time sensors. So that is extremely practical because the people need to take the decision every week or every day. So it's not one on top of the other. I think these two aspects needs to coexist.
I remember about 10 years ago having a winemaker tell us about how they had this cutting edge technology, which I think he called pressure bomb or pressure chamber,
Yes.
where you'd cut a leaf off a vineyard and then you'd put it in a little glass box and he would have to test 20 leaves one at a time. It would take him an hour or two and he'd still be only testing 20 leaves out of 1,000 vines or 10,000 vines. And you're now saying we don't have to be out there picking leaves. We can do that all digitally.
Yeah, so that pressure chamber, or the system water potential method, is extremely robust and the technique is very powerful. But as you explained very well, it's not easy to implement under field conditions. So experimental side, we do that a lot, but we understand the complexity to do that at a commercial scale because that takes time. And depending of the technique that you use, some of the techniques are going to need 1 or 2 hours just one leaf because it's a period of stabilization that you should wait. So what is happening today, there's 2 different type of approaches. One is remote and proximal sensing. So there's some remote sensing methods that are able to calculate the amount of water that is needed at large scale, block scale, or vineyard scale. There's other technologies that you can use with infrared thermography. So it's cameras mounted in a drone that you can also have an approximation of something very similar to this stem water potential value, but defined in small areas, so almost vine per vine. And the technique that we are promoting at this moment is in between, so it's block scale or per unit of irrigation area, because that is the area that you can control, and it's based on climatic conditions and atmospheric conditions or microclimate of that particular area. So it's a technique that can measure the amount of molecules of water that the system or the vineyards exchange with the ambient, and using those energy principles, we calculate the amount of water. So at the end of the day, it's more convenient because you're going to have a value that integrates a big area, and that is the value you need to take in consideration to calculate the amount of hours. So how many hours you need, how many millimeters of water you're applying to keep your vines in the conditions that you want. Because in viticulture, those values are extremely important because in general, we always want to keep your vines with a certain level of stress. But that threshold is extremely difficult to manage because if it's too much, then you have some problems. So that is why this type of techniques help a lot to correct that value, to maintain your vineyard in a good balance, more practical decisions every day. So that are the techniques that we can use today for that irrigation problem.
Did I understand you correctly that you were saying you can have sensors that detect moisture in the air, which then tells you how much water the vineyards need? Is that correct?
Yes. So actually, I just received the approval of the Water Research Commission to implement pilot experiments, mainly to show to the people that the technique can work. I have been working in this type of analysis for several years, and we're very confident from research experiments that the method can be accurate to calculate the amount of water that is needed. But through this project with the Water Research Commission, we're going to do pilot experiments in different areas with the intention to demonstrate that technology to the growers, because I think it's also very important that final part when you give that information to the real users. The best way for me is to show them, okay, this is the real information. We know that the system works the 95% of accuracy or 80, doesn't matter, but we disclosure that. So they know the limits of the technique and they know if that can work or not. So that is what's going to happen next season.
Amazing. So, I mean, if actually you can just measure moisture in air and tell so much about a vine, it begs the question then, are we able to predict future weather down to 10 minutes or half an hour? To what extent does that same technology extend to predicting flash floods or rain showers? And in South Africa, obviously, it's a big deal because our ripening windows are so narrow compared to many regions in, say, France, for example. And we've experienced it this year where you'll hear farmers saying, well, we hope the rain will last until Friday because we're planning on harvesting on Thursday. Surely by now, with those types of sensors, we're able to say, actually, we can know within 95% confidence that it's going to rain on Wednesday at 2:30. Do we have that kind of predictive power?
Yes and no, because one of the main technological challenges of these techniques is the frequency of gathering the data. So we're working at extremely high frequency, because obviously molecules of water exchange energy with the ambient. That is very rapid process. In 30 minutes of data, we collect a couple of millions of data points. What is amazing today with technology of 4G or 5G, we can transfer that information to a central computer and do our calculations outside of the vineyard itself. So that is amazing. Mainly those changes in data transmissions are now unlocking this type of possibilities. Also, sensor cost is lower, so that allow us to create a system with a price that is not extremely high, so that people can really access that. So I think those points are very important in these new technologies. In terms of what we can do for future predictions of weather or certain conditions, a lot of things are happening. Climatic prediction is working very well in a span of 10 or 15 days. And potentially this new system going to allow us in a 1 or 2 seasons to have enough information to train an AI system to predict certain events or be able to anticipate certain conditions with that range of, as I say, maybe 10 days or 15 days.
When we talk about AI in any sphere, I think the general public have their imagination captured by the almost human-like interactions with these systems. But it feels like, if I'm listening to you, the revelation, or rather the revolution in technology has come in areas that are perhaps a little less glamorous, and that would be the development of the sensors themselves, and also the ability to transfer, as you said, those millions of data points. How have sensors got more accurate? How are we actually gathering this data? Because we hear it all the time. If the information is not good, then the AI is not good.
Yeah, it's a topic that has been discussed a lot. So, for example, I have been invited to several symposiums and conferences to talk about the AI or new things with AI in agriculture. But the point that you mentioned is extremely important because the AI is a method to analyze certain information. There's another part, as you say, the revolution has been in other areas of this technology. So cost of the sensors, so they're small sensors with better capacities, the way that we can analyze data transmission, putting all of that information together in databases, all of that is behind of this type of things because we need to provide to the AI systems an infrastructure of data. And for me, that's going to be the revolution. At the moment that there's certain people also from international institutions that said that the power is on the data. Who owns the data and who can manage data at different layers is the people that are going to have the power to take certain decisions. In agriculture, it's a challenge, in viticulture as well, in particular because we are not used to gathering information in a systematic way. So we have been discussing with SA Wine and other entities how we can improve that, how we can help the growers to generate basic information, but solid and constant over many years. So we're starting also concept application with the vineyards that we own at the university. So we want to try to create a framework or a demonstration system that the people can follow in the future, maintaining data for long-term periods. I think that is extremely important. So we are competing with companies in Europe that they have an amazing databases. They're fully available for people to work with those databases. Climatic data are freely open in Europe, in Latin America, in Australia, in New Zealand, but here in South Africa, not. So we need to change also our mindset and look how we interact with that information and provide good things for the future.
At the beginning, we talked a little bit about electrical conductivity. Obviously, to have accurate electrical conductivity readings, you need the sensor. And then you were saying you can put the sensor on a quad bike or a tractor. But that obviously still requires someone to go out driving the quad bike or the drone or the tractor. But I understand you guys have now already been developing autonomous vineyard scout robots. Can you tell us a little bit about that project?
Yes, there was a project that was done by some of my colleagues here in the department. They established a collaboration with the CSIR. The main focus of those projects explore the concept of an autonomous vehicle that can navigate in a vineyard, gather certain data to extract 3D structures of vineyards, water conditions. So we install a set of sensors on the robot and we analyze the information that was obtained by the robot. But I think today the tendency is to move in for a more practical approach, something, for example, simple that you can attach in a tractor that can give you GPS capabilities because you're going to have certain actions in the vineyard with a tractor. The normal practices. Yeah, or maybe a small drone that can fly between the rows. There are changes in that concept because I think A full robot to do operation is not extremely practical. My idea is to focus more in what we can do with the data. We want to focus more in how we can give value to the growers using some technologies and artificial intelligence analysis on data.
Something that did occur to me is the idea of wearable technology. And I remember when Google Glass first came out, everyone got very excited about it. And then it died down because of privacy concerns. And now Meta have released their kind of wearable smart glass products. And again, people are getting bent out of shape about privacy, perhaps validly. But it occurred to me that sort of application could be extremely useful for vineyard workers who do have to be out in the vineyards anyway during harvest. Are there examples of this sort of technology like smart glass that can take a workforce that perhaps has a low skill level and give them capabilities they otherwise wouldn't have?
Yes. So there have been a lot of work in the area of using images. And all of that can be implemented in certain systems supported by a machine or a vision system. We don't have projects at the moment running, but in literature we can find some examples, very interesting approaches when people was using computer vision support systems to help laborers in the vineyards to take certain actions like a bunch thinning. So which bunches should be removed. So the system take a probabilistic approach and is telling to the person with colors, okay, cut this bunch and keep this one. Or inside of a bunch, for example, in table grapes, you cut certain areas of the bunch, shoulders and other portions to give more space to the berries to grow. And those vision system also with color scales can tell the operators, okay, those ones are the right that you want to cut. In the past, we worked in a couple of projects using technology from video games, Kinect sensors, to calculate the 3D structure of plants and also bunches. Maybe not at the level that is something ready off the shelf that you can take and implement in your vineyard, but a lot can be done just with your cell phone. I think that is the first entry point. There's a big tendency today to use normal cameras, RGB, for example. So RGB is the camera we have in our cell phones. We have been working in projects to detect leaf roll, mildew infections, just taking images and training AI models to understand the features in that picture and give it certain information. We're doing the same to calculate a bunch volume, bunch mass in order to try to predict yield. So apps and methods that you can use with your cell phone, because plenty of capabilities in the cell phone that is in your pocket that is fully available for you. So GPS coordinates, camera, certain power to process internally in the cell phone. You can start doing certain analysis or sending that to a cloud to do a more complex analysis.
Did I understand you correctly that you were saying someone can point their cell phone camera at a bunch of vines and the camera will highlight different bunches in different colors, almost like a kind of augmented reality that would then tell you, okay, the red bunches you need to cut off. Did I understand that correctly? It sounds almost like a version of Pokemon.
Yes. Theoretically, yes. So the approaches have been done using the glasses. But in a certain way, the computer vision technology allow us to do something similar with a cell phone. Yes, so that method that can first identify where are the bunches, and when you have that identification, having some algorithms that can tell you keep these ones or remove these other ones. Yeah. So that is in the theory. So it's nothing yet available particular in that sense. So we're working very hard in that domain with master students, PhD students, try to develop those algorithms. So at this stage, we're solid focus on the detection. So are we able to detect bunches with computer approach and artificial intelligence? Until which point we can detect all of them, because there's occlusion. Some of the bunches are covered by other bunches and some of them are covered by leaves. We are trying to evaluate in which trellis system that can work better, making some changes in the angles of the camera. Yeah, so we're in that phase of research. Something very simple that we published a couple of months ago, an AI method that we take pictures and we identify the phenology, so the phenological stages. For example, if the plants were in flowering or they were or berry set, etc. Looks and sounds very simple, but when you need to do that for 3,000 plants per hectare and in 20 or 50 or 100 hectares, that is extremely complicated. So that is also a nice point with the AI and technologies, that the scale of work, that you can manage that better because the machines can work 24 hours in a row, and in a couple of seconds you can analyze thousands of images.
What many wine lovers may not consider is what is required to analyze even just 100 hectares of vines as opposed to 1,000 hectares, or to produce 1,000,000 bottles of wine at a high quality is currently incredibly difficult. But what you're saying is there may be no need for wine to get any worse as the production goes from 1,000 bottles up to 1,000,000 bottles.
Yes, the new tendency is now to have certain consortia or big companies or big investment groups that they take control of multiple vineyards. So that happened, for example, in Chile and Argentina, big areas in California, Australia, and I think also going to start maybe happening here in South Africa soon, because it's a marketing and also market focus in terms of big companies taking control. And it's a reality. And at that moment, if you are managing 1,000 of hectares, it's extremely complicated. Extremely complicated because it's one person taking decisions. And imagine the number of data sources that you need to have in your mind. Yeah, products that you apply, irrigation, people, actions, cost, transport, materials that you put in your vineyard, until the point that you have your fruit, then you have your cellar. So it's extremely complicated. And all of these technologies, independent if they're from the vineyard side or from other angles, is just to put the information in the right way, and that something that can be easily accessed. And if I need to know something specific, I can do that with AI very quickly and focus on that particular aspect. With traditional methods, almost impossible. So then you need a group of people just looking where is that info. Or if you want to know what happened 3 or 4 years ago in an area, or if you want to know why this block is much better than all of the rest. We have an amazing wine from this area that is not the same for other areas. Something maybe climate, soils is different in that part. And if you have the information, you can replicate. You can learn that, let's say, that concept of digital terroir, and try to replicate that in the areas that you want to increase your quality, for example.
I just love that idea of, well, now you have 40 data points from this vineyard and you can guess very accurately why that wine is so good. And I always hear winemakers and viticulturists talk with almost an attitude of mystification, if that's a word. Like they're like, this block always delivers the absolute best, and we don't know why, but we just know every year this is the best. And this is our prized single vineyard block. But actually, there may be a little patch of barren land 50 meters away or 100 meters away, which has the exact same conditions, and they just didn't ever know that. So I guess being able to analyze a site properly, you can then also possibly replicate that or find sites that tap into that.
Or other way around. If you know that certain areas they're performing very bad for many, many years, maybe with the data you can discover why. Maybe something simple to correct and you don't need to do a huge investment. I was working, for example, with certain companies in 1,000-hectare olive orchards. That is very similar in terms of a vineyard application, because quality of olive oil can also increase if you apply certain deficit irrigation. And we discovered with satellite images a particular area, and we highlight that section for the managers, and they tell us didn't visit that area for 4 years or 5 years, because in a big area that is not easy to access. That is the reality. Simple technologies like scouting with a drone or a satellite can help you to recognize those patterns.
Yeah, you said something earlier when you were talking about troubleshooting. You talked about perhaps there was an infection in that particular vine or in that section of the vineyard. I believe the University of Stellenbosch is currently working on a project where you might be able to use a simple cell phone camera in order to detect leaf roll virus. Can you tell us a little bit about that project?
Yes. It was a project led by a plant pathology department. We, from our department, we collaborate with plant pathology and with engineers as well. A nice focus in terms of interdisciplinary approach. So you see plant pathology, viticulture people, and engineers working together. We finished the first phase of that project. That AI system, using normal RGB images from a cell phone, is able to detect if the leaf is infected or not, with a high level of accuracy, but also in the ones that are not showing very clear symptoms, like white cultivars. Because in red cultivars, there's a change of colors of the leaves that is very easy to detect, but in white cultivar, that is not obvious. We are moving now to a higher scale approach. So we submit to SAY a new concept proposal. So the idea is to use that initial phase, scale up to a canopy level per vine, and also implement drone technology. So with the intention to tell the growers the level of infection in this block is 20%. So you should keep it. Or is an infection of 90%. So the best option is to remove and plant clean material. Yeah, because that is something that industry is telling us. So that they don't have that capabilities. So they cannot do ELISA tests that they use to really be sure that the infection is there in multiple points because it's expensive. So they want to have something quick and with good accuracy to take decisions. So what am I going to do with this area? And on top of that, what is the effect? So if my block is infected, is it really something that's going to affect my yield or my quality? There's a plenty of space for research still in that domain, but our focus is going to be like this second phase of provide something in terms of rapid scouting of leaf roll.
We've been talking about how both at scale and coming down vine by vine, that it's becoming increasingly easy to make very accurate assessments at a granular level. And I spent 10 years in specialty coffee and there was this trend of analyzing particle variability in coffee grinders. So if a good grinder would grind all the coffee particles to be roughly the same size, and a bad grinder would have this massive spread of tiny dust particles and big boulders. And guys would really get very finicky about their coffee, as I'm sure you can understand. But they would freeze coffee beans because it would fracture differently. And then there was this time-consuming process of sieving out coffee grounds so that through a series of sieves, you could isolate one particle size and you could brew your coffee with that. And I wasted many years of my life sieving coffee beans.
Yes.
But probably the most depressing part of all of that was that actually the coffee wasn't getting any better. So we were spending ages reducing particle variability, but the coffee in the cup was, if anything, slightly less engaging. And I wondered if there is a parallel in viticulture. I mean, we are getting better and better at being able to accurately assess what is wrong, what is right, how much water they need, is it virused, is it happy, does it have exactly the right amount of stress? But what is the work done to connect that to the wine getting better? Or is that kind of completely removed? How do you view that from a philosophical perspective?
Yeah, no, from a philosophical perspective and also for a practical perspective. I think here in South Africa, we have a huge advantage in terms of the type of degree that we offer at the university and other institutions. So our degree is viticulture and enology. So the viticulture they have the ability to understand next steps to do wine. They know all of that. And the winemakers also, they should know very well what means produce the fruit and the quality of that fruit. I think that connection that looks and seems very evident is not so evident in other cases. Because, for example, in my experience in some areas in Europe and in Latin America, viticulture and enology are two different degrees. And for example, in Chile in particular, enology is a diploma on top of the agriculture degree. So I think we had an advantage that the people can connect these two different aspects. They are fully connected, but in the reality, if you do very good approach in your viticulture practices and you give the best fruit, and then in the cellar, if they mix everything, then you lost all of that effort. That is a concrete example. So in a block, in just a single block, you can have 2 or 3 different quality levels by the terrain, by the soil conditions or slopes, etc., etc. If you mix all of that, at the end, the quality going to be diluted. But if you are able to do something else in the cellar, isolate the areas that you have better quality, test that fruit, mix with other areas in other blocks, maybe with a similar level or high level quality, then things start changing a lot because you can change the price of your final product. You can do the mixing of certain things that you are looking for as a winemaker to give more complexity, to give more acidity in this area because the viticultural conditions were different. I'm going to mix with this other block area. So it's more granular in the sense that you can manage these small batches. I think the people in the industry start going in that direction. I think that is something that probably going to start experience soon. But that approach can change the rules of the game. Because the common approach is you harvest everything, you put everything together. Sometimes you put fruit with bad conditions, but mix with fruit that was perfect. And that is extremely common. Or you mix fruit from different areas, or when the people also approach multiple areas at the same time. I fully understand the logistics at the harvest are complicated and that require more intense planning from the beginning. But I think if the people take that, really look in that approach, changes can be extremely evident in your final product. That is the wine quality at the end.
So you're saying actually you can use drones or any number of sensors in your vineyard to go, okay, actually this section must be harvested now. This section shouldn't be harvested.
Yes.
This section has some rot. And so you've got all that data, but actually the human making the decisions still needs to decide, am I going to go to the trouble to keep all of that separate or not? And I suppose maybe it's about equipping the human to make the decision.
My feeling is that the people now is getting conscious of the effect of that. It's quite common that in a block, in one just single block, you have areas that are ready to harvest and other areas that you can maybe wait 1 or 2 weeks. And that simple decision make totally different wine style at the end. So all of that, what you did at the beginning, needs to be considered and taken very serious at the harvest moment. So that is what I said here in South Africa. As the winemakers, they also have a strong background in viticulture. They can understand that. They can really understand and they can interact with the person that is in charge of viticulture practices. That is something that we should do more. And I think if we're able to do that more and having that a common practice, I think the South African industry can make a shift in terms of quality and getting higher and higher.
Yeah. Your point is worth repeating, is that what we're doing with AI or the processes that are unfolding now is we're finding ways to connect more and more data points, right? So if you can connect soil chemical makeup with aspect, with measurements of terrestrial radiation, with rainfall per year, you can come to a really meaningful decision about what you should plant in that section. And what you're talking about is perhaps the more old school idea of actually just you need to have people who are connected to one another. You need your viticultural team to have connection with your winemaking team. And ideally, both of them should be familiar with both. And I really love that idea because I think as we get more and more technologically advanced, we often think that will replace the need for human collaboration and connection. But I feel actually those connections are quite important, especially if people are going to specialize more and more, then we're going to need those connections. And I chatted to the team from Leeuwinkale recently who have this absolutely incredible AI interface connected to the speed at which the wine presses operate, how much contact time they have with the skins, how much agitation there is, and it shifts in real time to make sure that the wine comes out a certain color. Now, they've connected that to an actual Pantone, and I thought, what's the good of that? Color is not as important as taste and flavor. And you'd say, well, what you'll find is that the connection to that color actually drills down to being a connection to pH, to levels of anthocyanins, to levels of flavor compounds. The kind of big revelation there was that he was gathering this information not to make a Frankenstein wine or to make a manufactured wine, but rather so that he could do as little as possible to the wine. So in one sense, the wine became purer. So he was saying, because I know exactly the makeup of this wine, I don't have to do anything to it. I don't have to add any acid. I don't have to adjust color. I don't have to... That was actually the opposite of what people think. They think, oh, if using all AI, it's basically becoming a factory, a kind of lab where we create soulless products. And wine will be soulless, but actually this knowledge allows us to operate in a purer way.
Actually, always with these technologies, we try to connect with something extremely basic, that is buying balance. So that concept is extremely simple. It's keep your vineyard in a balance. So means that you have a certain amount of leaves that can gather sunlight, convert that into the carbohydrates that ripe that fruit, and you keep that balance. So your root zone is good enough to replenish the atmosphere demand, and etc. And then the plant, then your pruning is very simple. Your canopy management is not very complicated every year. Your irrigation is also well done, etc., etc. You have enough airflow in your canopy, so then your disease pressure is less. It's like very basic concepts. And so we are not pushing out of the boundaries of the system like a create, as you say, it's like a Frankenstein plan or factory in destroying the nature things. No, it's totally opposite. So actually we are trying to understand as much as possible what is the optimal condition to keep the system running in a good connection with the environment. So these systems are not against the sustainability. It's opposite. Yeah. Actually, more data, more information, you can have better sustainability. And then how you implement that in the winemaking part is extremely important, because the concept I always repeat to my students is If you have good fruit, then the winemaking part is very straightforward. So you don't need to do a lot of corrections, or you don't need to add acid, or you need to do magic in your cellar to have a good wine. So I think that is the concept that we should look for, is less intervention that is due to the effect of better decisions at the right moment and with the right sources of information.
But that really is beautiful, because the entire movement of natural wine, if we were to sum it up, would be no technology, no additives. And it was this kind of desire to go back to the pure processes of winemaking. Yes. But the irony is that what we've been talking about today enables the purest expression of winemaking that the natural movement would never be able to achieve. So it's almost like this technology is enabling us to make wine more naturally than ever before.
Yes, at the end, that sounds maybe not very clear, or it's not very simple to see that connection. But yeah, I think you're totally right. So that is the point. So to be able to produce, let's say, organic wine, actually you need to know a lot about what happened in your terroir, what happened in your area, or try to have less pressure of pest and disease. Obviously, you need to know where you should control. And to do that, these techniques can help you to say, okay, these blocks are complicated, these areas has more pressure, and why does those areas are under those conditions. And you can also learn from your experience, from your historical data. So what I did wrong or not wrong, or what I did that was not optimal at that moment. So was my pruning, it was my irrigation, I did a wrong nutritional plan in this area, there was too much nitrogen, too little, etc., etc. It's giving us that capacity to understand better the system, and from that taking decisions that we can promote sustainability. So we are working very hard from a research perspective. I think this type of conversations and the way that this information is expressed to the industry is important, in the sense that there's a lot of missing points, or points that are not clear when the people see or they try to understand what they can do with the technology. So I really invite industry people to be in contact if they like to share some information with us, or if they're not sure of some technologies or certain things. So we also want to create a community that can understand these technologies, because thinking from a more practical point of view, it's difficult to be on top of everything that is happening extremely fast. Every day new things appear, so we can help in that process from the university perspective. The end goal is to have something nice for our industry.
But Professor, yes, I know I've taken up way more time of yours than I said I would, but can I ask you one more question about the future? What are the technologies that are perhaps on a 10-year horizon that are exciting you the most, and how will that change viticulture?
I think for me, what's going to change the rules of this game in the maybe 5 years or 10 years is the way that we can approach AI to learn from the data that we are collecting at this moment. I think AI itself, the way that we organize the data and all of that, that is the thing that's going to change the rules. Technology, sensors, I think we have a very good or clear vision of what is happening, the limitations and the conditions of the sensors. So I don't see that something very particular going to appear in that sense. I think what's going to happen, just my opinion, is that the technologies that we have going to evolve and be better performance, better data transmission, low cost, less power intensive. I think at the end, all of those changes with similar technologies or similar principles, they're going to facilitate the people to start using that in the reality. But the main change for me is going to be at the moment that we're going to be able to use that information through this AI system at different levels. Viticulture level, wine marketing, I think is something extremely powerful that's going to happen probably soon. Preference of consumers. So there's plenty of sensors that can be used to detect unconscious signals of people when they taste wine, or why the people now is changing certain perceptions. Was incredible for me having some discussions with colleagues in Mexico. So I attend a conference for table grape with table grape producers in Sonora in Mexico, and they told me the massive changes in terms of preference of consumer now for looking only white cultivars in the USA marketing. And it's also something's happening now with the wine consumers. So for me, AI going to be the technique, give us certain clarity to take decisions.
I suppose that's the final connection. We've connected soil to the vines. We connected vines to the viticulturists. We said there was a need to connect the viticulturist to the winemaker. And I guess that final link is to connect the wine to the actual consumers.
I think that final connection is actually one of the most important, because I think in the wine industry, we push for a certain wine style that has been a concept for many years. So this is the wine that we are targeting. But probably in the future, going to be other way around. So is the marketing or is the consumer that they're going to tell us, okay, this is the wine that I'm looking for.
Yes. Thank you so much, Professor. And thanks for all the extra time you gave me. I really did appreciate you being so generous with your insights and expertise.
No, thank you for the invitation. And maybe a last message from our side as a digital viticulture group. We're a small team of people here in South Africa that we want to do some changes. And it's an open invitation to our industry members to be in contact with us.
Thank you so much.
Thank you.
We've reached the end of another episode of the ViniMark podcast. If you enjoyed this episode, consider subscribing to the ViniMark channel so that you can join us for more conversations around wine commerce, wine science, cellar mastery, marketing, and the rising trends amidst the industry's more adventurous pioneers.